Good morning, and thank you for attending the webinar to learn how to integrate RISA-3D with IDEA StatiCa. This workflow can help you to avoid manual inputs and to save time by importing the geometry that it's already modeled. So let's start. A reminder that we'll have a Q&A session at the end of this presentation, so feel free to submit questions in the GoToWebinar panel during the presentation and we'll respond it through the chat or at the end. The agenda for today is this list. We'll focus on the RISA-3D and IDEA StatiCa integration. However, we want to introduce Checkbot and available integrations we have with other applications. Later, Johan will explain step by step the process needed to import a RISA-3D model into Checkbot. Now, I'm going to use a short video to introduce our Checkbot application.
Are you struggling to navigate the multiple software platforms necessary to carry out connection design? Are you finding that manually transferring data between these systems using spreadsheets is often a time-consuming and error-prone task? With IDEA StatiCa's extensive BIM links, you have not one, but 3 ways in which you can streamline your connection design workflows, allowing you to 1. Import, 2. Update, and 3. Share your data without the need for any manual data re-entry whatsoever. Design your structures in your CAD software, including all critical details such as welds, bolts, cuts, and stiffeners. Once your design is ready, using our Checkbot application, you can automate the transfer of your complete design data directly into IDEA StatiCa. Now, you can design and co-check your connections safely and accurately in IDEA StatiCa. But what happens if you need to make changes to your initial design? No problem. Perform your updates in your CAD software, and due to the seamless data flow, you will see your changes appear automatically in IDEA StatiCa. Need to assign your design to an external colleague or supplier without an IDEA StatiCa license? Not only can you visualize the model in our free 3D viewer and import the data before fabrication, you are also able to share the DWG, IFC, and the connection file with them. You can even get inspired by over 1 million ready-built real-life connection design templates in Connection Library. Automate the repetitive by optimizing your workflows and eliminating manual errors. Download your free 14-day trial and calculate yesterday's estimates.
Okay, now let's talk about the supported integrations to Checkbot. So if you come to our website, you can always come to the BIM tab and then you can click over supported integrations. That's the website I am in right now. So then you can start scrolling down here and look for your preferred software. So you can see that we have links to global analysis software and also BIM and detailing application softwares. So if you keep scrolling down, you can look at the different applications. If you click in these boxes, you'll get more information about the link. And you can also click on the different tutorials we have for these different applications. So you will see a step-by-step process, and in some cases you can also download a model from those applications. All right, so now let's jump into the RISA-3D demonstration. So Johan will take over from here.
All right, so today we will start the RISA-3D and IDEA StatiCa integration. Before we do that, there are 2 files that are needed from RISA to be able to cover the integration. The first file is the SAF file, or the simple archive format file. With this file, we will be able to bring in the geometry, cross-section, and materials for the entire project. Within this type of file, the end reactions are possible, but are currently not being shared by RISA-3D. So this brings us to the second file that we need, and that is the member end reaction forces. Within this type of export file, we will be able to have the end reactions results for all the members and also include all the load combinations for the entire project. With these two files, we will be able to complete the integration so that it reduces manual work and also improves the efficiency of the integration. Now, to begin with the first part of the workflow, we will start in RISA-3D in order for us to be able to export the two files that we mentioned, those being the SAP file and the member end reactions results. For the second step of the workflow, we will be creating a new project within Checkbot. Within this project, we will then be able to import the SAP file into Checkbot and review the geometry of the entire project. Now, once everything has been reviewed, we can move on to the third step, and that is where we will be opening the connections from Checkbot and using the Excel import tool to be able to load every single joint that we need. The fourth and last step, that's where we will be modeling and designing the connections that are not possible in RISA Connection. All right, so let's go ahead and start our workflow within. Starting in RISA, the first thing that we need to do before exporting our files is to be able to change the global coordinate system. So with a SAP file, you are not able to use a Y vertical axis. You actually need a Z vertical axis. So even if you try to create this export with a Z vertical axis, RISA will give you an error message letting you know that, hey, you need to change this vertical axis to a Z vertical axis. Now, to be able to do that, all we need to do is go to the Settings tab, access our axis options, and then in the very first option, the vertical global axis, we will change from Y to Z. Then if we click Apply, all of our current results, if you had already ran this model, will be erased and you will have to rerun the entire analysis again. Now, before we go ahead and do that, we need to go ahead and check our forces, because changing the global coordinate system from Y to Z can affect the loading directions of some loads, especially member area loads where you might be able to reference the global coordinate system, thus affecting the direction. So we can go ahead and quickly turn on our basic load cases and start reviewing the rest of our loads. And as we can see, all of these different loads kept the same directions. In any case, if they don't keep the same directions, you can always go to those basic load cases and adjust their direction. Now that we have verified that our loads have stayed the same, we can go ahead and run this analysis again. Now here is the batch results that I want, and that is so that I include all the results for every single load combination that is used within this structure. Now, once I have obtained my results and I have ran my analysis, the last thing that I need to do is save the project. So once I've saved them, I will also save the results. And from here, I can begin exporting my two files. The two files that I need again are the SAP file and the Excel file. And to access that, we can go to the File tab, select Export option, and we can begin with the SAP file. So here under the SAP file, you will be given basically the location of your previously saved project, or maybe the location of where your RISA file is being located at. So here I can go ahead and save this Excel file or the SAP file. So I will name it SAP and click Save. Now, once this SAP file ends, uh, once this SAP file finishes exporting, we will be able to start exporting the second file, which is the member end reaction results. All right, so once the SAF file has been exported, we can go ahead and do the same thing for the member and reaction results. So let's go ahead and go to File, Export, and select Excel file. Now here, under Load Combinations, we can choose to export an individual RISA results section. And for the drop-down menu, let's go ahead and select Member and Reactions. Let's go ahead and click Export, and we can go ahead and save it on the same location where we have our other SAF file located at. So here we'll go ahead and save it. And now we have the two files that we need. I've exported those two files that we needed. There is one additional thing that we will need to do before we can access Checkbot, and that is adjusting the SAF file that we exported from RISA. So let's go ahead and locate that SAF file that was exported and go ahead and open it. From here, we need to go to the Structural Curve Member tab located at the bottom. And from here, we need to locate the column L for the local coordinate system. So here, what we will be doing is changing the Y by vector to C by vector. Now here we need to change it for all the members. So that's what I'll go ahead and do. I'll go ahead and copy this cell, select the rest of the cells within the same column and paste it. All right, now that it's pasted, I'll go ahead and save this file. Make sure that you close this file because otherwise you will not be able to open it in IDEA StatiCa. For the second part of the workflow, what we need to do is to create a new Checkbot project and then bring in the SAF file so that we can review the geometry of the project. To begin, we'll go ahead and select the Checkbot icon within the IDEA StatiCa window. Once the window opens up, we will be able to create our new project. So here we'll go ahead and name it RISA IDEA Integration. You can then go ahead and select the different design codes or subcodes available. Once it's ready, select Create Project, and from here we can begin the import process. To begin this import process, all we have to do is select the SAF file import option located on the upper ribbon on the left side. Here we then need to locate the location where we last saved this SAF file. Here I already have the correct location, so I'll just select it. Now that the project has been imported, we can begin the review process. So first, I'll go ahead and turn off the member labels. And from here, we can go ahead and start reviewing the geometry of this entire project. We'll go ahead and look for rotation of all the members to see if they're correct. We can begin with this part of the project. I'll go ahead and go back to the RISA project. From here, I'll change the view of the members from wireframe to render view. I zoom in here. I can see that this I section is rotated. This I section is not rotated. If I go back to my Checkbot project, I can then confirm that these rotations are correct. Now these are for the symmetrical cross sections. As you can see, this will be your I sections, your HSS sections. But if we look at the non-symmetrical cross sections, such as your L sections, C channels, T sections, those you will have to look out for because their import rotation might not be correct. And if we take a look at these trusses, compare them with what RISA has, we can see that the rotation is not correct. Now, this does not go to say that it cannot be fixed. What we can do is go ahead and select the member. We already see the description of this cross section. But what we can do is go ahead and create a new cross section, but this time this cross section will come directly from our cross section navigator. So if I go select a double angle section with the same description, 102 by 102 by 7.9. From here, the option that I will have will be mirror by y-axis. If I select this option, I will be able to mirror this cross section, and if I click OK, I'll have the same cross section and the correct rotation. Now that this member is rotated correctly, we might want to do that for the other members in case you want to design the rest of the connections. So if that is the case, what you can do is do a multi-select option. So we'll go ahead and select the rest of the members. Since we already predefined this new cross-section, we can go ahead and look for it under cross-section. And this will be the last option, which will be the newest cross-section that was created. Now that our members are rotated correctly, we can then begin designing each and every connection that we need. We are now on the third part of this workflow, and this is where we are looking at the connections, opening them, and most importantly, we're looking at how we're going to be loading them. The second part being the most important, this is where we're looking to cover the load import tool. We're going to see how to download it, how it works, and loading a sample node as an example so that we can show you how to transfer the loadings from the import tool onto IDEA StatiCa. So to begin, we will open a non-typical connection, and it will look at this specific node. For example, there is an HSS connecting to a wide flange column as well as a rotated wide flange beam. Now, if we go to the top view, we can also see that this wide flange beam is also at a skewed angle. So this will make it a pretty interesting connection to just look at in modeling it. So now to open this connection, all we have to do is just select that node. From there, you will see that it will be highlighted in this tree of connections. Now, once you select it right here on the right-hand side, you will see more information about that specific node. Things such as the name, the connected members. This is pretty important just so you can verify that the members that you see around that node are actually connected to it. Now, to open it right here on the top, we'll just select this open button. Now that our connection is opened up, this is where we will be able to do the import for the loadings. To begin, on the top ribbon for the loads option, we have the XLS import. Let's go ahead and select that, and in here we will be given some useful information. One of them being the order of the loads. This is pretty important when working with the next step where we need to identify all the different members and their end types so that we can bring in the correct loadings for all the different load combinations. In this section, this is where we will be able to paste all the different load combinations at once. There will be no need to bring in every single load combination separately. Now, the next thing that we need to do is to download and open the RISA-3D import tool. This import tool will be used for filtering and adjusting the member and reaction results. So these results will be filtered based on the selected members and its end types, as we discussed about this order of loads. So to do that, we'll go ahead and access IDEA StatiCa website. From here, under the BIM tabs, we can select supported integrations. Under the supported integrations, here we can find all the different applications that we integrate with, one of them being RISA-3D. If we scroll down, we'll see that there is a RISA-3D IDEA StatiCa workflow link. This is basically the same workflow that we are talking about right now. And if we go to the second tab, we'll be able to see that at the very beginning, we'll have the RISA IDEA load adjustment Excel template. If we click on this link, we will be able to download the RISA IDEA StatiCa import tool. Now I have already downloaded this import tool, so let's go ahead and take a look at it. Now this import tool is from an Excel file, and it's divided into two separate sheets. The first one being the Excel export results, and the second one the end reactions. Under the end reactions, here is where we will be pasting all of the member end reactions that we exported from RISA-3D. Once we paste all of these member end reactions, we can come to the XLS export results sheet. And in here, all we have to do is input the members and their end types. So here on the right-hand side, we have an example on how to access them. As mentioned, we can select the XLS import, and on the new window, we can see the order of the loads. Once we have that, we can click Start, and then all the different loads will be filtered and adjusted for the right order so that you can just copy and paste all of them. Now let's go ahead and verify the member definitions and the member end reactions for the selected node that we have. If we start at this node, let's go ahead and exit this window. We can see that we have these two members already and the continuous column making this node. If we go and further out and look at the checkbot model, we can see that this node consists of this continuous member and the two beams. If we remember from RISA, they provide member end reactions for their forces. Now, if we were to obtain the member end reactions for this column, what will end up happening is we will end up getting the member end reactions for this location and for this lower location. Whereas the actual end reactions that we need for this particular node are the end reactions at this node, from this side, upper side, and from the lower side. Now, we don't have to go ahead and destroy this checkbot model. What we can do is we can go ahead and go back to RISA and split the member into three separate parts so that we can have end reactions at those nodes. And the way to do that is just going to RISA. If you select the member, in this case, I've already split it, but if you select a member, on the top for the member options, we have the option to split these members. So once you have split them, you can always rerun the analysis and export those results. Now, if we want to also verify the member directions, the member definitions, we can also do that by turning on the local coordinate systems and the INJ end types. Here in RISA, to turn on your INJ end types, we can always go to the Home tab. And on the right side for the quick view options, we can always turn on the INJNs. So with these INJNs, we can verify that the bottom member is a J-end and the upper member is an I-end, as well as this rotated white flange is from an I-end and this HSS is on a J-end. If we go to the connection, to turn on these local coordinate system on the connection, on the upper ribbon for the labels, we can always turn on the LCS. And from here, we can always verify as well. Since the X direction is from left to right for M325, this is a I end. This HSS will be a J end. And here, since the X direction is ending for this side, this will be the J end, and this will be the I end. And the third and last option to also verify that with is with the member labeling as we discussed. Begin means in IDEA StatiCa for this purpose, begin means J end and end means I end. So with this, we've already verified that our directions and member definitions and our end reactions are correct. Now, since we split up the members, we already know which one is the begin and which one is the end. So whenever it comes time to providing the member labels and the member end types, we can always go to RISA and provide the new member label, which for the bottom will be M298 and for the upper will be M303. So if we go to the load import tool and from there access the end reaction sheet, in here, this is where we will be pasting all the member end reaction results that we obtained from RISA. So I've already opened this file. If we open it, from here we can now begin copying all the reaction force results that we've obtained. So I'll select from columns A to J starting on row 3. And from there, select everything and copy it. Now I can go back to my loader import tool and starting on A3, I can now paste. And now I have all the results for every single member and all the load combinations. From here, I can then go to XLS export results. We can start typing the members in the correct order, that is M323, M325, M298, and M303. For their end types, that will be JI, JI. Now that we have both the member and the end type information, along with the entirety of the end reactions, all we have to do is click Start. Once we click Start, all this information will be brought in into the XLS export sheet. All right, now we have all the different load combinations for the specified members. Let's go ahead and copy all the forces. Once selected, let's go ahead and go to our connection. And here under the XLS import, we can go ahead and select the very first cell for the very first member and Control V to paste all the different load combinations here. As you can see, all the different load effects have already been pasted. Now, if you have existing loads and you don't want them to be shown along with the ones that we just imported, you can always check this option for replace existing loads. Let's go ahead and click OK, and then all the different load effects will be pasted onto this connection. Now, one way to verify that the import of these loads are correct and that the RISA IDEA load import tool works is to look at our unbalanced forces. If we look at all the unbalanced forces for every single load effect, you will be able to see that all the different values are either 0 or very minimal values. The reason why we might see some minimal values, this might be because there are adjustments on members such as offsets, or maybe we have additional lateral forces such as earthquake loads. In this case, our loads seem to be balanced, and from here we can now begin modeling our connection where we can look at this non-typical node. I'll start with member M323, the HSS, so that we can create its connection. So to begin the connections, I can go to Operation, and here these are all the operations that I need to be able to create my connections. They range from simple operations such as cuts and openings to combined operations where you can find base plates, splices, end plates, and much more. For this case, we're using a connecting plate combine operation. And from here, we can begin the process. So here, we already selected the correct member, member M323, but we need to change the related member. This needs to relate to the column, so that is 237. The thickness will be 3/8, and I will just adjust the width and the depth. The second part, this is for the connection. This will be the position of the connection. The thickness, I will make it the same as the gusset plate, so that will be 3/8. Now here for the alignment, the alignment and the type, there are different types of connections that we can create. This one for now is the cap plate, but for the design of this member, instead I will choose notched member. So here I will be given the dimensions for that specific plate. So this will change to 3.5, 7 inches, and 6 inches for the overlap. Now here I'll reduce my welds. This will be 1/4 of an inch, as well as the tongue. If I go to side view and transparent view, I can go ahead and create the position of my bolts a lot better. So here for the rows, I will do 1.5 inches for the initial edge distance, and then 3-inch spacing for the next bolt, and this will be on the vertical direction. Now, if I want my bolts position in the middle, I will just leave it at 1.5 inches. All right, so with this, we have basically finalized the connection for the very first member, member M323, and now we can move on to member M325. And since this member is at a skewed angle, we can begin by creating the shear plate connection from the column web to the member 323. So to add a single plate by itself, that will be part of the basic operations. So if I go to operations, the basic operations are in the first and fourth row. So here, if we look at this operation, this will be for a stiffening plate operation. Now here for the stiffening plate operation, this is one of the most basic operations for a plate, which also gives you the most freedom of placement. So here we can always go to the origin, and in the origin, we have many different options. The option that we like to use the most is usually member or member LCS because you can obtain the member directions. In this case, if we use member LCS, I can do the method by angles and I can reference the correct member. In this case, it's member 325. If I go to top view, now my plate is in the direction of that member, but I need it perpendicular to the direction which will be adding a 90 degrees. So here for my rotation on the Y, if I do 90 degrees, now it's the correct rotation. So here for B1, I'll go ahead and remove its dimensions. Then I'll do 9 inches and 3 inches for both H1 and H2. This is how the plate should look like. Now that we have this, we can move on to the next operation, and that will be a cut of plate so that we can begin cutting this plate. So operation, and now I'll go ahead and select a cut of plate. Now this cut of plate, we're going to use it so that we can cut the plate that we just created by the column so that we can also be able to add the welds to it. So here I already have it, SB1. Now instead of 323, this will be 237. For the cutting method, there are different options. Instead of using bounding box, let's go ahead and use surface. And now I can specify a double-sided fillet weld with a 1/4 inch. As we can see, this connection has started already. Now we have the plate welded to the column. Next thing that we need to do is create the attachment from the member M325 to that shear plate that we created. So to do that, we can go ahead and open a new operation, and this new operation will be again another connecting plate operation. From here now we just have to re-reference everything again. So here it will be 325 for the new member. Now for the connected to, instead of creating a new plate, which is something that we don't want, as you can see here, what we can do is choose an existing plate. For the existing plate, we can now select the plate that we created for that skewed angle, which is SB1. If we move further along with this connection, for the position, it will be 9.5 inches. For the thickness, let's go ahead and do 3/8. And for the alignment, we can go ahead and leave it at the front, but for the cap plate, so that we can avoid any eccentricities, we can do cap plate double-sided. All right, so now if we keep going, for the plate length, this will be 3.5 inches and 6 inches in depth. The thickness of the cap plate, this will be 3/8 of an inch, and also of the offset, that will be 3/8 of an inch. The cap plate will be a rectangular shape, as we can see here on our model, and then we can start adding the bolts to this connection. So to do that, let's go ahead and go to a side view and turn on the transparent view. And if we want, we can go a top view so that we can see the position of the bolt. Now for the horizontal position of these bolts, we want to place them at the center. And to find out the overlap length for these two plates, we can always open up the measuring tool. From here, I'll go ahead and select two edges or corners, and from there, I'm giving the overlap, which is 3 inches. And as you can see here, the initial position now it's at 2 inches. So we'll go ahead and adjust this to 1.5 inches. And now for the vertical position, it will be the same one that we have for the other connection, which will be 1.5 inch edge offset and a 3-inch spacing for the next bolt. Now that we have this, the next thing that we need to do is to reinforce the column for these connections. And to do that, we can always add them through the stiffener operation option. So we'll go ahead and turn this back to solid view, and under operations, for the basic operations, we can select stiffener. So we select stiffener, we'll just select the column as the member, M237. Now here for the related to, instead of member, we're going to relate it to the plates, and we're going to relate it to SB1. That way it provides additional support at the ends of that plate. Here I'll just go ahead and adjust it to 1/4 and edit my weld as well. As you can see, I kept the location on both sides and the position on both ends for the upper and lower bounds. If I rotate this connection, this is how our connection is now. The next thing that we want to do is to create the welds between the stiffeners and the shear plate for the connection on member 325. I will be using a cut of plate operation so that we can be able to create these welds. Now, we don't have to go ahead and obtain a new operation. We can always copy our existing operations. And since we already defined a cut of plate, we can go ahead and copy that one. Select this one, right click and copy. And we just have to redefine our parameters. So for cut of plate, modified item is SP1. Here, if we hover over the plate on the bottom left corner, we can see the information about that plate, such as the name, material, and thickness. So now this plate is not being cut by the member, but rather the stiffener plates. And here the correct one to choose is either stiff 1B or 1D. Stiff 1B being the upper stiffener plate. Now that we have the correct weld and on both sides, we can go ahead and copy the same operation and do the same thing for stiff 1D, which will be the lower plate. And as you can see now we have both welds on the top and bottom plate, as well as having the full connection finished already. Now from here, all we have left to do is just to run our analysis and review the results. To do that, we can click on calculate. So now that we have the results on the top left corner, this is a summary of the results for the most extreme load combination. And to see the detailed results, we can always go to the check tab and turn on our equivalent stresses and strains so that we can see the behavior of the connection. From here, all that is left to do is to check the components for the entire connection, that is the plate checks, the bolt checks, and the weld checks. From here on, if the connection checks out with its results, you can always save it into Checkbot. So we click Save. Your connection will be saved, and then you can exit connection. And now here in Checkbot, your connection will be displayed, and you can begin working on other connections. Now, if your connection is within a group, you can always apply the same design to the other connections that are within the same group so that you can make the design of the other connections a lot faster. But this basically covers the entire workflow. Now, last thing, we will be uploading this recording, but if you also want to work on that on your own pace, you can always go to the website and access this RISA-3D import workflow. You can always go through it, and it involves basically every single step that we went through. And the last tab is basically an explanation and differences between the LCS and the member forces of IDEA and RISA. If you want to keep a printed version, you can always create a PDF. All right, so now let's go ahead and check to see if we have any questions so that we can answer them in this time that we have left. Okay, so now that we have covered the entire workflow, let's go ahead and conclude with the benefits that this integration between IDEA StatiCa and RISA offer. So first, you are able to take control of all of your connections, meaning that you can have all of your connections all in one place, including the simple connections and the non-ordinary connections. Within IDEA StatiCa Checkbot, you are able to group your connections, so you can model only one connection and then apply the design to the rest of the connections within that group. By using IDEA StatiCa Connection, you will be able to model those non-ordinary connections that will sometimes include those unique plate geometries. Within IDEA StatiCa, you are able to model those plate geometries, or you are able to import those geometries as a DXF file. IDEA StatiCa also offers 6-axis loadings, meaning you are able to analyze your connections based on load combinations without having to resort to load envelopes. IDEA StatiCa also offers an extensive database of their cross-sections, as well as allowing you to create your own built-up sections. Since IDEA StatiCa uses CBFEM, you will be able to obtain a complete understanding of the load path, meaning you will be able to create better decisions about the connection. And IDEA StatiCa not only offers the regular code checking of the connections, but we also offer more advanced analysis. Some of these crucial analyses that we also allow are buckling analysis, stiffness analysis, and capacity design for seismic connections. Since RISA does not offer a direct link with IDEA StatiCa, this is why we have to resort to the SAF file export and the end reaction exports. But this does not mean it's the same case for all other software. As you can see for eTabs, they do offer a direct API integration which eliminates manual steps. With this integration, you are not only able to export the model, but the loads altogether into Checkbot. As you can see, you can observe all the different load combinations for the entire project. And once you get into the connections, you are able to see the load combinations for that specific connection, which in turn allows for a faster, more efficient workflow in the IDEA Statica with the global analysis software. Now, if you are interested in these workflows, you can find them in IDEA Statica under our BIM links. All right, so now with this, we can go ahead and go to our Q&A and see if we have any questions to answer for today.
All right. Well, thanks, Johan. Yeah, we'll get to questions in just one sec here. Just wanted to mention some next events that are coming up. So next week, our group of us will be out at NASC in Louisville, Kentucky. So if any folks will be out there for the Steel Show, we'll be at booth 106. So come by and say hi. We'll also be doing different demonstrations throughout the day. Johan and Andrea and a few folks will be giving demonstrations. So definitely come by and chat with us. The next webinar coming up is on April 30th. It's on the new 3D detail and anchor reinforcement and baseplate design. So lots of exciting stuff to learn and see there, and kind of seeing the new work that we're doing. So with that, let's dig into some questions, Johan, if you're ready. A couple questions that were coming through at the beginning, and feel free to send more questions as you have them. You can input them in on the panel. But first question, they asked, does the default RISA local member access convention also need to be changed? I think this has to do with when you were modifying the vertical global axis. So they're asking if they also need to change the local member axis.
Okay, no, the local one does not have to be changed in the RISA application. The reason we're adjusting the global coordinate system for the vertical axis is because that's how the SAF file is created. So unless it's changed, if you don't change the vertical axis, you will get an error message from RISA stating you have to change it before you can export the SAF file.
Okay, gotcha. How about another question? Why do we need to change that column in Excel? So basically changing the LCS to the Z by vector, because they're asking, wasn't that already changed in RISA?
Right. So the one that we changed was the global coordinate system, and inside the SAF file, that's where we're adjusting the local coordinate system of every single member. So every single member is defined by their vertical vector. So it's y by vector. If we were to do that export with y by vector, the members will be rotated horizontally because in IDEA Statica, the y-axis is horizontal. So that's why we're changing it to z by vector so that when it gets to IDEA Statica, it's on the correct vertical axis.
Okay, great. Another question here, they're asking about how would IDEA Statica behave when a RISA model, oh, no, sorry, wrong one. They're asking about why split the member. So you had that scenario with the angled beam where you split the member, and they're asking about, is it to input loads for equilibrium analysis? And they're saying, instead, can you not evaluate that connection with just the member and reactions of the connecting members and allow the continuous column to just have an unbalanced reaction?
Right, so both scenarios are possible, but here what we're showing is basically the scenario where you can import all of your end reactions, even for the bearing member, in scenarios where it is continuous. That is the main reason why we're splitting up the members, but as the user asked, you are able to just turn off loads in equilibrium and just use the connecting members.
Gotcha, okay. Another question, in the Excel sheet, they saw Impera units and metric units for IDEA. So is there any kind of direction you can give regarding units and reactions?
That I would have to get more clarifications. I was looking at the kind of end reactions from RISA, and these are in Imperial, and also here when we're looking at the RISA import tool, they're also on Imperial. If we also look at the connections, the XLS import option. It's also on Imperial. So maybe if we can follow up with that, or if you can let me know exactly where you saw the metric options.
Okay, all right, gotcha. But yeah, you basically kept it Imperial the whole time, right?
Correct, yes.
Yeah, okay. Another question, talking about the unbalanced moment. So they're asking, does the unbalanced moment on the column get updated automatically as the eccentricity changes based on the connection?
So IDEA StatiCa does take into effect those offsets that you are inputting in the connection. So you're applying those loadings. Once the analysis is being run, those offsets will be included in the analysis, and they will be taking their effect on the connection.
Okay. And then this is regarding the connection that you were modeling. They ask, can we weld the flanges and the web to the column instead of having so many plates and bolts?
Right, yep, that's totally possible. It's up to you the type of connection that you want to make here. I just went with another connecting plate operation, but if I were to kind of turn off these operations, I can always create a cut of the member. And by creating the cut, I can extend the member to the column flanges and the web. So here I can specify member 325 being cut by the bearing member, which is 237. And I can specify, instead of bounding box, I can specify surface. And from there, you can see I can create those cuts. If I want this to be extended over, I can probably also do bounding box, and I can extend the member farther apart. From there, I can just copy it, and I'll create a surface cut. And then I can just do double-sided fillet weld for both options. So as you can see, you can probably end up running into some conflicting scenarios for the other connection, since this I-beam is a little bit on the longer side, along with its angles. But yep, definitely, if you just wanted to weld the member, bolt the member, there's really no limitation.
Okay, great. There's a question about the load combination names and that those don't transfer over. Do you have any guidance to add on that, or do we have anything
So
that we're working
currently,
on
yeah,
our side?
that's correct. Currently, that is what happens whenever it's imported, it gets renamed. The one thing I would say that the order is kept the same. So maybe there could be some guidance where LE1 corresponds to the order of the loadings with that given name. But yes, this option of being able to keep the loading name is being worked on, or has been asked to our developers, so they are looking into it.
Okay, perfect. Another question, I think they're sort of asking about batch design in Checkbot, and it asks if you were assigning the connection to other nodes and it was found that the design was inadequate at one of the locations, would there be a notification that pops up stating that the loads are too large? Or can you kind of just describe what happens there, Johan?
Yes, definitely. So here, as you can see for this import, IDEA StatiCa automatically groups your connections either based on the type of member or the type of cross sections or the amount of members. Here we have 4 group connections with the similar geometry in this arrangement. So if I wanted to group them, I can always group them. After I create the group, I can always make this connection the parent connection, and from there I can calculate all of them. I don't have to design or model the rest of the connections. Once the analysis is finished for all of the connections, on the left side, that's where you get the status. You either get that check mark, a here where it states that you have to run it, or you get a red X stating that the analysis failed. If it failed, you can go into a particular node, open it in connection and see what exactly failed or which exact plate or which exact fold is failing.
Okay, great. Well, another question for you. Once the RISA file is updated and a joint is changed, would it delete the connection you made at that joint? So I think they're basically asking, if you make changes in your RISA model, how do you interact with that with Checkbot and with IDEA?
So here, if we update it, we'll have to redo that connection. But one thing that can be done is once you are in, let's say, your previous model before you update it, you can go ahead and save this connection under your connection library. So you can just click publish. If you click publish, you have a little window where you can publish it, maybe just for your personal license. That way, you don't add connections to the rest of your company if you're just using it to transfer it to the other checkbot or to the updated checkbot model. So here you can save it. Once you save it, it will be under your connection library. So whenever you open that new empty connection, you can then click propose, and then once you have saved it, it will appear on the window. Here, particularly, we won't see anything because I haven't saved it, but it will be saved under either your personal or your company connection library. So the workflow will be save it on connection library, then open the empty geometry, and then apply that saved connection from connection library, and you can keep on revising that connection.
Okay. Another question sort of about batching and loads. They're asking if there are a lot of connections that are all the same that you want to analyze as a group, how do you determine the worst case loads to import? And kind of how do you apply the loads to those connections?
So you would go about applying the loadings to every single connection. And then once every connection has the loadings, you can run the entire group for analysis. And as mentioned, you would get that X mark stating that that particular connection failed, and that might be the one that's the most critical since it's failing the current design or the current model.
Right, so you don't necessarily need to envelope your load and apply it to the same loads to each connection. You can use unique loads on each connection, correct?
Correct, yeah.
Let's see, there's a few more coming in here at the end. Another one kind of similar vein, they're asking, do you have to manually bring in the loads for every connection that you are looking to design using the Excel tool that you showed?
Yes, you would have to manually apply them, but once you are in the import tool, you already have the entire results. So all you have to do here is just adjust your members and your end types. You'll click start, and then you can just select all the reactions and then just apply them here in the Excel. So yes, it's still the manual work, but the most of the workload has already been done at the beginning.
Yeah, still going to be a lot faster than just typing them in on your
Right.
own, right?
And the benefit is you're importing all of the load combinations, so you don't have to go one by one. All of them will be imported at once.
Yeah, yep, that's right. Another kind of question digging into grouping and how we do that in Checkbot. They're asking, what is the rationale behind the assignment and grouping of typology and arrangements? And they ask also, are those automatic?
Yes, this is automatically done during the import. But if you want to remove kind of the groupings, if you want to do your own grouping, you can always go to the connections, right click, and under the grouping by, you can adjust it if you don't want to have any groups. If you just want to go by the topology, or if you want to include both the topology and the cross section for the different arrangements. So here, if we go through, let's say maybe, let's go through a smaller arrangement. So if we go kind of, this is really large, we can keep with this arrangement too. So if we go through all of these, you'll see they have the same geometry. So these are the opposing side of the connections. So all of them will have the same geometry and the same cross sections, and since that's the type of arrangement that we created. But again, you can create your own arrangements as well.
Okay. We're getting kind of near the end of time, so we'll finish off with one more question that kind of leads us into the next webinar. They're basically asking, can you give us a preview on anchor reinforcement? And they said they're looking forward to that. So do you want to just give us a little teaser, Johan, of what the anchor reinforcement topic is, and maybe kind of tell us what it's used for?
So the anchor reinforcement, what's coming up will be IDEA StatiCa Detail 3D. So currently, right now, it's only available for Eurocode, but now we have it available for ACI 318. So the deal here is you can start with your steel to concrete connection in IDEA StatiCa. As some of our users may know, our concrete on connection is unreinforced. So for those critical connections where you have extreme loadings, you're probably seeing concrete breakout failing. With IDEA StatiCa Detail 3D, you will now be able to export those results from the anchors in IDEA StatiCa Connection. And in Detail 3D, you can model the reinforcement and the anchor reinforcement along with it so that you can do the appropriate supplementary reinforcement on the anchors. Now, you can always start from zero, from a typical concrete block, and from there, you can always model the reinforcement, apply the anchors, and you can also apply your own loadings. So right now, I'll just go ahead and show how it will be looking. But again, for the upcoming version now, it will be fully available for version 25. So here, as you can see, you have an entire 3D model. You are able to apply any reinforcement. You can apply the anchors. So here under transfer devices, this is what we are using to apply those different loadings. And so in here you have different options, and the options are anchors. So this is a really good topic for those of you who deal with these type of connections that are needing to reinforce your base plates. You will be able to do this with the upcoming application.
Okay, cool. Yeah, looks exciting. Well, with that, I think we'll call it for today. And yeah, we're looking forward to seeing anchoring coming up on April 30th webinar. We also will have our new version of the software, version 25, coming out on April 23rd. So if you have the software, make sure you look for emails to update that, or you can always go to the website to get the latest downloads there. So thanks everybody for attending today. There were quite a few questions just about the steps in the process. So if you want to go hop on our website, the link on the far right here is the one to get you through the kind of step-by-step process of that. And as always, we send out an email with the recording and all the additional info. So that'll go out automatically. Same thing with the PDH certs. So thanks everybody for joining today, and have a good day. We'll see you. Bye-bye.